So in this session, let us look at the operations on sets. So operations on sets அப்படினா இப்போ ஜெனரலா நமக்கு நம்பர்ஸ் இருக்கு அப்படினா நமக்கு என்னெல்லாம் ஆபரேஷன்ஸ் தெரியும்? Arithmetic operations, addition, subtraction, multiplication, division. So how to work with numbers அப்படிங்கிறதுக்கு தான் இந்த operations யூஸ்ஃபுல்லா இருக்கு. அதே மாதிரி with sets you will have a couple of operations. And என்ன அந்த operations என்னது? Something similar to addition, subtraction, multiplication, division in your numbers. Okay. So first case, இப்போ இதெல்லாம் தான் operations. The ones that you see now, these 6 operations, these are the ones. So let's discuss each of them. Union first. Union அப்படின்னா என்னது? Let's take two sets for this. Okay. So eraser. Okay, I'll judge. Fine. So X union Y is defined as a set of all Z where Z is an element of X or Z is an element of Y. Okay. So what do you understand in the notation நம்ம வந்து முன்னாடியே பார்த்தாச்சு. So X union Y is a set of all Z where either after whatever comes after this line is a condition that Z should satisfy, correct? Where Z is either an element of X or an element of Y. Okay, so let's try to prove this, understand this using Venn diagrams. Okay, so let us take this as set X, okay, and let us take this as set Y. So before we proceed, I hope you know the parts in a Venn diagram. By parts I mean which part denotes which set and so on and so forth. So idu mattum, like this part, okay, so this represents only X, right? Only elements that are in set X. Similarly, this part represents only elements that are in set Y, and this, obviously the intersecting part, represents the elements that are in both X and Y, and the entire thing is the elements in X and Y put together. Okay, that is what is X union Y. So how will you represent this now? Now X union Y will be all of this, correct? Whichever is in X and Y, because that is what the definition says. It is a set of all Z where Z is an element of X or an element of Y. It can either be an element of X or it can be an element of Y. Okay, fine. Next, what is an intersection? Now this intersecting set, now note the notations, okay? So this is the notation for union, just a U that we write, it's a common English letter. Then for intersection it's an inverted U, okay? It's an inverted U for intersection. So X intersection Y is a set of all Z where Z follows satisfies the following condition, okay, where Z is an element of X and Z is an element of Y. Okay, so this is the difference. Here in the case of intersection, this Z is an element of X and is an element of Y, but in the case of union, X is either an element of X or an element of Y, correct? So now let's try to represent this using Venn diagrams. Again we take set X, set Y, edutuma, okay, X, Y edutache. Now where's my blue color? Okay, so idhe madiri. In this case, how did you represent? Z was an element of either x or y. So you shaded the entire region, x and y, both the sets, correct? But either z should be an element of x and y. Okay, so this entire circle is your x, this entire circle is your y, but there is only this small part which has both x and y, correct? So all elements that are a part of this region in this Venn diagram are the elements in this set x intersection y. Okay, fine. Next, set difference. So there are two notations to this. Let's take x minus y is one notation, or you can take x slash y. Okay, x slash y. So both these mean the same difference. Okay, so x slash y is defined as a set of all z where z is an element of x and z is not an element of y. Okay, so let's try to understand this. Okay, let's understand this. Just a second. Let's draw the diagram. You have set x, you have set y, x and y. So x difference y is a set of all z where z should be an element of x. So this x kulla irukano z. Okay, it should be in this circle, but it should not be a part of y, so it should not be in this circle. Okay, so first of all, remove this circle from the result that you are supposed to get. Okay, so when you remove this circle, what are you left with? What are you left with? You are left with only this region, correct? Only this region. What is this? This region is a set of all x which does not have y. Correct. Now this intersection region has x and y, but it has y. Okay, so since it has y, we are not supposed to include it because x difference y does not include y. In other words, what do you mean? You have some set, this set, entire set. So from x, you are subtracting y. Okay, from x, you are subtracting the region where you have y. Okay. So what is remaining is your set difference. Okay, and that is this area. Clear? Let's move on to symmetric difference. Okay, so symmetric difference x. So this triangle is the notation for symmetric difference. X symmetric difference y is equal to x set difference y union y set difference x. Okay, so this at first sight looks a bit confusing, but it's very easy. It's easy. Let's take x, let's take y. You have x, you have y. So yeah, so what color is more? Let's take green. X set difference y. First x set difference y. Another x set difference y is this region. Correct? It is not including intersection part. Y set difference x and y in the region. Correct? You remove x, you subtract x from y. That is what you do here, right? So y set difference x will be this region, and the union of these two, I've shaded both in the same color, so and the same pattern. So this by itself now represents this symmetric difference of x and y. Okay, so x and y symmetric difference is the entire area of x union y except x intersection y. Okay, fine. Next we move on to what is called complement of a set. Okay. Now complement. To understand this, let us first take the Venn diagram, two sets X and Y. Let us also take another set which is the universal set. Okay, and we define this using a capital U. Now this is different from this U. Okay, this U and this U are not the same. This is the notation for universal set and this represents union. You can also represent universal set using this symbol. Okay, this is some E symbol or epsilon symbol, whatever you call it. Okay, you can represent using this symbol. So let's take U. I hope you won't get confused. So in this case, complement of a set X. Okay, so complement of a set X, say, is what? Is U difference X is equal to complement of set X with respect to U. Okay, so what does it mean? If you take color for this scenario, okay, for this scenario, let's draw the diagram, let's shade the region. It's complement of X, so it is a set of all elements that is not a part of set X, so it should be the entire region other than, and this is with respect to the universal set. Okay, this is with respect to the universal set, so you include the universal set also and shade the entire region. So just to put things in perspective, the universal set or example universal set can be the set of all let's say natural numbers. Set of all natural numbers are universal set. So starts from 1, 2, 3, 4, etc. and so on and so forth. X is the set of all even numbers. Okay, and set Y is the set of all multiples of 4. Correct. Now even numbers and multiples of 4, both these are a part of universal set, right? Even numbers are 2, 4, 6, 8, 10, 12, etc. etc. This is a part of the universal set. What is the universal set? Set of all natural numbers. Natural numbers another 1, 2, 3, 4, 5, 6, 7, 8. So 2, 4, 6, 8 and etc. which are a set of even numbers, which is set X, is a part of the universal set. Agreed. And that is why you have drawn X, this set X, inside the universal set. Okay, inside the universal set. Similarly, you have set Y, okay, which is a set of multiples of 4. Another multiples of 4, 4, 8, 12, 16, 20, 24, so on and so forth. Now all these are also natural numbers, correct? All the set of all multiples of 4 are also natural numbers, and that's why you've drawn set Y also inside this universal set. Okay, so that is also clear. In addition to that, obviously you have couple of numbers. I mean, all multiples of 4 are of course this example is not correct because all multiples of 4 are even numbers, and so set Y will completely be a subset of set X. Okay, so just for the sake of example, okay, so you have an intersection also. Fine. So I hope you understood that. Next, similarly, let's see we represent another complement set. Let's say we represent U complement set difference Y. This is going to be Y complement with respect to U. Okay, so let me take another color, red, say. So this is going to be what? So what do I shade in red? Other than Y, everything. Y தவிர எல்லாத்தையுமே shade பண்ணோம்னா, that is this set. Okay, that is U set difference Y, which is a complement of Y. Okay, it's nothing but Y தவிர எல்லாத்தையுமே எடுத்துக்கிறோம் in the universal set. Understood? Fine. So again, going back to, let's say if you take this set difference, what is this X set difference Y? It is nothing but the complement of Y with respect to X, correct? Correct? Now you don't have a universal set defined in this case. Okay, you've taken the complement of set y complement of set y, அதாவது y தவிர எல்லாமே, right? Y தவிர எல்லாமே you've taken in set x. So it is y complement with respect to x. Okay, fine. So you can kind of relate complement and set difference. Okay, so that's the idea. Next, let's take disjoint sets. Disjoint sets is another, obviously the name, as the name suggests, ரெண்டு செட்டுக்கும் காமனா எதுவுமே இருக்காது, சரியா? So if you take set x and set y, the intersection of these two sets will be a null set. எதுவுமே இருக்காது. In terms of Venn diagram எப்படி represent பண்ணுவோம்? x இங்க இருக்கும், y தனியா இருக்கும். There is no intersection. There is no connection at all between these two. There is no intersection. Okay, so these two are completely disjoint sets. Fine. Okay, now let's see a couple of other things in this. In the union, what do you observe? Now set x is a subset of x union y. Do you agree? Yes, x union y is this entire set, mottama shaded region, but x alone, this x set is a part of that, correct? So x is a subset of x union y. Similarly, y will also be a subset of x union y. What else do you see? This intersection region, correct? So x intersection y will be a subset of x union y also, correct? So these are three things that you observe in the union of sets. Intersection la paatha enna theriyudhu? What do you see in intersection set? X intersection y is a subset of x, correct? Similarly, x intersection y will be a subset of y, correct? And x intersection y, obviously you know, will be a subset of x union y. Okay, but in this case it's, you don't have to discuss the last property. Okay, then what do you observe? Set difference. Okay, idhila you need not discuss all these. Okay, I hope you understood all these. Fine. Now there is something else in your textbook. Yeah, you have a couple of useful results listed out. Okay, let's try to prove each of these using Venn diagrams. First one is A difference B is equal to A intersection B complement. Okay, so let me get a new screen. First property. Okay, property 1, A difference B is equal to A, what is that? A intersection B complement. So this is the left hand side of the equation, this is the right hand side of the equation. Let us take LHS. Okay, LHS at the point. You have two sets. You have set A, you have set B. Okay, and you have a universal set also. You have a universal set. You have set A, you have set B. Okay, fine. Now what is A difference B? What do you know of that? A difference B is B complement with respect to A, correct? B complement with respect to A. In the region mattuma, this region alone, right? It is this region alone. Fine. So this is LHS. You've represented the left hand side of the equation using a Venn diagram. Now let's take the right hand side of the equation. What do you have? So again, draw Venn diagram. Close out U, that is universal set. You have set A and set B. Okay, now B complement. What is B complement? First, take B complement. B complement another other than B, everything else in the universal set. Okay, so that is all this. All this other than B. B thavira idu ellame. Okay, so you have all this B complement. Now what they are asking for is A the intersecting part between set A and B complement. What is that? Intersecting part between set A and B complement. Idu mattum thana. correct? So this checkered lines, this blue and green line, rendume vandu enga irukku, that region. Okay, what do you see now? This region is similar to this region. The shaded region in LHS is equal to the shaded region in RHS, right? So it's proved. Obviously A set difference B is equal to A intersection B complement. You've proved it. Okay, so first is proved, done. Let's take the next one. What is the next one? It's B set difference A equal to B intersection A complement. This is just the same. Okay, onnulla inga A B irukku, inga B A irukku. Okay, so I hope you've understood the first proof, and this is going to be exactly the same. A ku badala B, B ku badala A. Okay, fine. Let's take this one. What is that? A set difference B equal to A. Okay, it says it's the third one, right? A set difference B equal to A is implies and implied by. Okay, that is what it means. Implies and is implied by A intersection B is a null set. Okay, so what is this? Intersection B is null set. Okay, fine. So first of all, let us take this part. Okay, so what it means is, if this is true, this is true. If this is true, this is true. That is what this symbol means. Okay, is implies and is implied by. Okay, fine. So let's take this part first. The A difference B is A. Okay, this one. What does this mean? A set difference B should be A. Okay, let's take one example. This is A, this is B. Now what is A? A is this completely, right? This is completely. Okay, this is completely A. Okay, that is the RHS. RHS. Okay, now let's take LHS. Have A, you have B. A set difference B another. So other than B, everything in A, correct? That is this region. Other than the intersecting region, correct? Now is this equal to this? Are the LHS left hand side and the right hand side of the equations equal? No, right? They are not equal, because inga the intersecting region add pannirukom, right? Obviously that is what set A is. Set A is inclusive of the intersecting region, but here A set difference B is not inclusive of this region, correct? So what does it mean? Whenever you have an intersecting portion, this won't be true, correct? If you have an intersecting portion, this won't be true, correct? So definitely what you have done here is wrong. This example is wrong, totally. So you have to take some other example. What example is that? You have to take an example where A and B are disjoint sets. What do you mean by disjoint sets? They have no intersecting area. Okay, they have no common area. In this case, what do you observe? Set A will be this alone, correct? And A difference B is what? B tavira A, correct? B tavira elame A la irukkiradhu. That is again this, correct? Now it is equal. Now this is correct. So if you have two disjoint sets, disjoint sets A and B, then A set difference B will be equal to A itself, correct? You observe. What do you know about this again now? In this case நம்ம என்ன பார்த்தோம்? Disjoint sets இருக்கும்போது the intersection of the two sets involved will be a null set, correct? இதுதான் நம்ம முன்னாடி பார்த்தோம். Yes or no? Correct? So you have A intersection B is a null set, which is this, correct? So if this is true, this should be true, is what we've proved now. Because if this is true, A and B should be disjoint sets, and if A and B are disjoint sets, A intersection B will be a null set. Okay, reverse path on another. If A and B, if A intersection B is a null set, if A intersection B should be a null set, there is only one way. Okay, these two should be disjoint sets. Kandipa disjoint sets. And if these two are disjoint sets, obviously this will also be true. That is what we've seen. Okay, so vice versa. Hope you understood. Fine. So this is done. Let's move on to the next case. What is the next case? A set difference B union B is equal to A union B. Oh my god. Okay. A set difference B union B equal to A union B. Okay. Now let us take the left hand side of this equation. You have what? You have set A, you have set B. Okay, fine. So another first let's take this A difference B another. We've already seen 1,000 times. This region, okay, this region. So this, you know, B is this entire set. Okay, so union of these two will be everything. Correct. A set difference B was only this region, okay, this region, but B is this entire thing. B is this entire circle, and you are supposed to find out the union of these two sets. So obviously this entire region. Understood? This green shaded region. Next, moving on to the right hand side of the equation, you obviously know, because you've seen this already, that A union B is this entire thing, right? A union B is this entire thing. So left hand side of this equation is equal to right hand side of this equation, so hence proved. Okay, fine. So next, A set difference B intersection B is equal to a null set. Okay, so let us take that. But before that, I think we are running out of time. We'll take that as a separate video. Okay.